Mars, the next great frontier in space exploration. But this time, it's not NASA or SpaceX making headlines. The United Kingdom has been quietly developing one of the most advanced Mars rovers ever built, a machine designed to unlock the planet's deepest secrets. What makes this rover different? Why is the UK investing in the Red Planet? And could this be the mission that changes everything we know about Mars? The UK's journey to Mars has been a long and determined one. While the nation may not be the first name that comes to mind in planetary exploration, British scientists and engineers have played a crucial role in many groundbreaking space missions. Now, the UK Space Agency and the European Space Agency (ESA) are leading a revolutionary mission, one that could redefine our search for extraterrestrial life. Development of the UK Mars Rover. The UK's Mars Rover, part of the ExaMars mission, is named Rosalind Franklin after the pioneering scientist who helped discover the structure of DNA. Unlike previous rovers, this one carries a game-changing technology, a drill capable of penetrating up to 2 meters beneath the Martian surface. Why does that matter? Because at that depth, Mars' harsh radiation can't destroy possible signs of ancient life. For the first time, humanity will peer beneath the Martian crust, looking for the biological fingerprints of microbial life that may have existed billions of years ago. The rover's journey began as part of a collaboration between the UK Space Agency, ESA, and multiple European partners. The goal was to create a rover with cutting-edge instruments capable of detecting organic molecules, analyzing soil chemistry, and capturing detailed images of the Martian landscape. Engineers in the UK, particularly at Airbus Defence and Space in Stevenage, have worked tirelessly to ensure that Rosalind Franklin can withstand the extreme conditions of Mars while carrying out its critical mission. The science behind the mission. Mars' surface is a hostile wasteland. The thin atmosphere, extreme temperatures, and relentless solar radiation make survival almost impossible. However, scientists believe that if life ever existed on Mars, the best place to find evidence would be underground. Rosalind Franklin's drill will extract soil samples from below the surface where organic molecules could still be preserved. These samples will be analyzed by the onboard laboratory, a suite of cutting-edge instruments capable of detecting the faintest traces of biological material. The onboard scientific equipment includes Pasteur Instrument Suite, a sophisticated set of tools designed to detect biomarkers and analyze soil chemistry. Pankom Panoramic Camera System, a high-resolution stereoscopic camera developed in the UK to capture detailed images and create 3D maps of the Martian terrain. Infrared Spectrometer, a tool designed to identify minerals associated with water, potentially pointing to past habitable environments. Raman Laser Spectrometer, a key instrument that can detect complex organic molecules, which could be crucial in the search for past microbial life. The UK's expertise in robotics and space technology has made this mission possible. Built by Airbus in Stevenage, the rover is an engineering marvel. It's designed to navigate the treacherous Martian terrain with 6 independently driven wheels, an autonomous navigation system, and a solar-powered energy source optimized for the thin Martian atmosphere. British scientists have also developed a state-of-the-art Pankom, a high-resolution stereoscopic camera capable of capturing stunning images of Mars' landscape in incredible detail. Additionally, the UK's investment in space exploration has been steadily increasing. With the establishment of spaceports in Scotland and a growing number of collaborations with ESA and NASA, Britain is positioning itself as a key player in planetary exploration. The success of Rosalind Franklin would not only demonstrate the UK's technological capabilities, but also lay the foundation for future missions, including possible human exploration of Mars. Challenges and delays. Like any ambitious space mission, the UK's Mars rover has faced significant challenges. Initially scheduled for launch in 2020, the mission was delayed due to issues with the landing system and later setbacks caused by geopolitical tensions that forced a change in launch partners. However, ESA and the UK Space Agency remain committed, and now the mission is closer than ever to reaching Mars. The launch is expected within the next few years, and when it lands, it could transform our understanding of the red planet forever. Another major challenge has been designing a rover capable of surviving Mars' harsh environment. The planet's surface temperature can drop to minus 125 degrees Celsius, minus 193 degrees Fahrenheit at night, and dust storms can last for weeks, obscuring sunlight and threatening the rover's energy supply. Engineers have had to develop innovative solutions, including improved thermal insulation and more efficient solar panels, to ensure Rosalind Franklin can operate under these extreme conditions.
The search for life. If Rosalind Franklin's instruments detect even the faintest signs of past life, it would be one of the most profound discoveries in human history. It would mean that life is not unique to Earth, that microbial organisms once thrived on Mars, and perhaps even beyond. This would fundamentally change our place in the universe and fuel the search for extraterrestrial life on moons like Europa and Enceladus, where similar conditions might exist. The discovery of even basic organic compounds would provide crucial evidence that Mars was once habitable. Scientists are particularly interested in ancient lake beds and river valleys on Mars, as these are the most likely places to find preserved biological material. If the rover uncovers anything resembling fossilized microbial life, it could prove that life emerges wherever conditions allow, suggesting that the universe may be teeming with life. Impact of the mission. A successful mission would solidify the UK's position as a leader in space exploration. It would inspire a new generation of scientists and engineers, attract investment in space technology, and pave the way for future collaborations in deep space missions. More importantly, it would bring us one step closer to answering one of the greatest questions of all time. Are we alone in the universe? The success of Rosalind Franklin could also have significant implications for future Mars missions. If the rover finds promising signs of life, it could influence the design of upcoming sample return missions, which aim to bring Martian soil back to Earth for further analysis. This would be a giant leap toward human exploration of Mars, as understanding the planet's past and present conditions is essential for designing safe and sustainable habitats for astronauts. The UK's Mars Rover mission is not just another space project, it's a turning point in our search for life beyond Earth. If this mission succeeds, history will remember it as the moment humanity came closest to proving that life exists beyond our planet. What do you think? Could Rosalind Franklin be the key to unlocking Mars' biggest mystery? Make sure to like, share, and subscribe to Atomic Domain for more mind-blowing space discoveries. Stay curious and keep exploring.